Alright, you guys, and now for number 4. Number 4 is hard. And so number 4 for part A asks us to show that the equation cosine 2x equals sine x can be written in the form of this. Okay? And so from here, part A is relatively easy, and part B just goes crazy. Which makes sense, because part B is worth 5 points. So if you take the time to learn this, you can get a whole lot of flippin' points. Okay? Anyways, so we're going to be writing a lot for this, and I'm probably going to need more space than this. So I'm going to be using my whiteboard over here. See? So here in this whiteboard, basically for part A, the main thing we need to notice is that we need to pass from cosine 2x equals sine x to this whole thing here, of course. But what is important about this? The thing that I'm putting right now in yellow only has sine. There is only sines going around, while originally we have a cosine. So if you get rid of cosine, you're good to go. Now, what are your tools for getting rid of cosine? Your tools for getting rid of cosine in your formula booklet, eventually, once you get familiar enough with it, and this is something I invite you to do. I invite you to study with your formula booklet. Get used to it, because the day of the test, you are walking in with the formula booklet. It is an additional tool that you can use. So get friendly with it because it's going to save your life. Anyways, eventually you find this. So these are the main tools you have for facing these type of exercises. Okay, anything that looks anything remotely like what they're asking here, you're going to be using these tools. And so these tools I copied and pasted over here. Okay? Yeah. So, for part A, now that we understand our tools and our approach and everything, we have cosine 2x equals sine x. And my only objective for now, because a lot of times we're like, oh, we need to reach this, and you focus so much on this, and you get like confused or whatever. The main idea is just get rid of cosine. Once you get rid of cosine, everything will flow. And so let's get rid of cosine slowly but surely. So which of these properties, specifically this 3, because we don't have tangent up here, so we're going to forget about that. Of those 3 properties, which ones could help me? Alright, so we can start off with the one that is down here. See? So for the one that is down here, it literally has cosine 2 theta. Now theta is just what's inside the cosine. In this case, we have, the x, right? Well, actually, this whole thing is inside the cosine, my bad. But point is, instead of theta, here we have x, but the formula works the same. So cosine 2x can turn into this here, okay? So if I go ahead and do that, okay, if I go ahead and do that, I end up with, on the left side, right, I end up with cosine squared x minus sine squared x equals sine x. And you might be telling me, dude, you're trolling, you still have cosine, and I'm telling you, hold up. The IB loves when you use formulas from the formula booklet. There is something planned up ahead for us. So the moment you do this, now this formula looks friendly, because this formula has the squares up there, the squared up there, right? And so this formula up here, you can rewrite it and leave cosine alone as cosine squared theta equals 1 minus sine squared theta. So all I really did was pass this guy to the right, okay? That's all I did. And so once I apply that formula here, I end up with 1 minus sine squared x minus sine squared x equals sine x. And yes, this looks kind of nasty, but hey, look at that. We just got rid of cosine. So again, a lot of times, especially for show that exercises, people get scared because the final answer is super scary and it's super long and it's super hard and all this stuff. But at the end of the day, focus on the small things. You started with cosine and sine, you need to end up with only sine. So use all the formulas and all the tools you have to leave it as only sine. So once we did that, reaching what they asked for is much easier. So on the one hand, we have it equal to 0. And on the other hand, notice, you have a -1 and you have a positive for the sine squared. Okay, so we want to leave sine squared positive and have it equal to 0. Those are like the main things we have to do. So if I combine over here, I end up with 1 minus 2 sine squared x equals sine x. And so here, first thing equal to 0, but also keep the thing that's squared, right? I need to keep it positive. Right now it's negative. So here I'm going to go ahead and take the courage to do plus 2 sine squared x plus 2 sine squared x. So this makes me end up with 1 equals 2, here's a squared, sorry, sine squared x plus sine x. And when you have a -1, which makes sense because I do -1 -1, I end up with 0 equals, and just to leave it as a show that, I end up with 2 sine squared x plus sine x -1 equals 0. So bada bim, bada boom. That is for part A. Not that hard. Just keep in mind the process. So with the show that exercise, you gotta go from stuff with cosine and sine to stuff with only sine. So use all the tools you have, and this right here is very important. Know the tools you have. Study with the formula booklet. A lot of students don't do this as much as they should. So if you're listening to this video, whatever point in time it is, whether you have the exam in 30 minutes or 30 days or 2 hours, study with the formula booklet, get familiar with it, have it open next to you at all times. There's no reason not to. That is for part A. Then for part B, we have hence solve cosine 2x equals sine x where blah. Okay, and I know some of you might be thinking, what the heck is going on? So basically, on the one hand, it says hence. See, anytime the IB says hence, it's kind of just, it's a big hint that, okay, what you did in part A, you need it for part B. Okay, so having that in mind, what you got to do is, first I'm going to show you visually what's going on. See, before anything, here, it's telling you the domain. Are you guys? And domain is possible x values. And whenever it says solve, in this context, it's going to be for finding the x-intercepts. And so basically it's telling you graph this, right? Graph this and find the x-intercepts within this domain, right? Now, I'm going to go ahead and pull up Desmos, okay, just to show this more literally graphically. So if you graph it, it looks like this. Now here, there are a lot of x-intercepts, right? There's this one, there's that one, there's this one, there's that one, there's so many, right? And so what they're telling you is that you need to find all the x-intercepts that are between negative pi and positive pi. So if I go back here, it's between negative pi and positive pi. So all you need to find are this one, and this one. And those are actually the answers. It's negative pi over 2, it's pi over 6, and it's 5 pi over 6. So this is just a bit of context of what we're doing and why we're doing it. Now, like any sine function, the cool thing about it is that it is an infinite cycle. It always looks the same. It always repeats. And so one of the main tools you have is that to visualize this more clearly, you can use the unit circle. And so because this is a repeating loop, so is the unit circle. It is also a repeating loop. And so the answers, the x-intercepts that we're looking for, are sort of hidden in the unit circle here. Okay? So that is the game plan. That is what's happening. That is the intuition behind the scenes. Now that we have that in mind, I'm going to show you the way to solve it, right? And so first things first, for part B, I'm using what I have from part A. So I need to solve this. Sine squared x plus sine x minus 1 equals 0. Now, because it equals 0, I mean, you're finding the x-intercepts because this thing equals 0, okay? That's the other thing I forgot to mention. You're finding the x-intercepts because this thing equals to 0. Now, from here, this should ring a bell. This should look a little bit familiar, and if you paid a little bit of attention in class, you might realize that this has to do with a quadratic. The IB loves to put quadratics hidden everywhere, okay? And here you have a quadratic because technically, if you go ahead, and this is something you do have to do, by the way, okay? Just to make it more friendly, technically, if you go ahead and call sine x, I don't know, let's call it m, okay? That means for this first part, I have 2m squared plus m minus 1 equals 0. And so, this makes a little bit more sense. So if I ask you to factor this, okay, if I ask you to factor this, find the x's, find whatever, see? Solving this is a lot more friendly, right? And so from here, there's two ways. So you can either do factoring, or you can do the quadratic formula. I'm going to use the quadratic formula just because, in my opinion, yes, it might take longer, but it always works, okay? Factoring is actually mega fast here, but I know some people just don't like factoring, so I'm going to show you the longer but more reliable way. So the quadratic formula looks like this. It looks like negative b plus or minus square root b squared minus 4ac divided by 2a. Now, what is a, what is b, what is c? This is all in the context of a quadratic. So your a is whatever is in front of the x squared. Your b is whatever is next to x, and your c is whatever is alone. So in this context, a is going to be 2, b is going to be 1, because there's a hidden 1 here, and c is going to be negative 1, of course, right? So if you go ahead and plug all of this in, and remember the quadratic formula is for finding the x-intercepts, okay, so is factoring. From here you can end up with negative 1 plus or minus square root of b squared, so it's 1 squared, minus 4 times 2 times negative 1, divided by 2 times 2. So this ends up giving negative 1 plus or minus square root of 1 plus, so it's 4 times 2 times negative 1. So it's plus 8 divided by 4. So from here you end up with negative 1 plus or minus square root of 9 divided by 4, same as negative 1 plus or minus 3 divided by 4. And so from here you need to apply the plus or minus because you gotta do what you gotta do. So once you apply the plus or minus, all you're really doing is saying, okay, there's one answer that has a positive and one answer that starts with a negative, right? So for the positive, I have negative 1 plus 3 divided by 4, and for the other one, I have negative 1 minus 3 divided by 4. So over here, you end up with 2 over 4, and down here, you end up with negative 4 over 4. So that means for your answers, on the one hand, you have 1/2, and over here, you have negative 1, right? Now, these are the answers thinking for m, right? So technically, because you replaced m earlier, technically what you just found is that one of the solutions is at m equals 1/2, and the other solution is at m equals negative 1, which is the same as saying that your zeros are at 1/2, 0, and at negative 1, 0. Now, because I replaced for sine, you gotta replace back. So technically, and you have to do this for getting full credit, here, one of your solutions is at sine x 1/2, and your other solution is at sine x negative 1, okay? So here I just found my x-intercepts for what I'm looking for, right? Now, because they put it in this domain, it can come in two different ways, okay? This is technically like an angle. See, I know we thought about it as domain, and visually it's very friendly to think about it as a domain. But in terms of the unit circle, which is the tool we have to use, this is really just an angle, okay? So angles can come as degrees, which is what we usually know, or as radians. And so follow the colors I just put. So degrees is going to be yellow, okay? Radians is going to be blue. And so in this image that I pulled up, okay, degrees is all these guys here. All of these are in degrees. It's usually what we face, okay? It's what normal people use. But sometimes radians is useful, okay? And so radians are here. Now radians and degrees are equivalent in their own way. What do I mean by this? For example, if you look at 30 degrees, okay, its equivalent is pi over 6. 120 degrees, its equivalent is 2 pi over 3 as radians, okay? And for 4 pi over 3, its equivalent is 240 degrees. And so, once we have that in mind, a very interesting thing happens that it's important to have clear, okay? Pi radians is 180. So pi radians equals 180 degrees, okay? So technically what they're asking for over here is the answers where you have negative 180 degrees up until x equals 180 degrees, okay? So these are saying the same thing. All right, that's just a bit of context because I know you've probably seen that somewhere, and I need you to understand that pi radians, okay, is just pi radians equals 180. All right, that's what I'm trying to tell you. All right, anyways, so from here, how do I find my solutions? And so from here, you have some of your solutions, right? The thing is, you need to transpose your solutions onto the unit circle in order to get the answer. So one of my answers was sine x equals 1/2. Your other answer was that sine x equals -1. And so where is sine x equals 1/2 and where is sine x equals -1 in my unit circle? Guys, sine, cosine, tangent all have something associated to it. So sine and cosine and tangent is oftentimes called the famous so, ka, toa. What the heck does so, ka, toa mean? So is opposite over hypotenuse. Ka is adjacent over hypotenuse. And toa is opposite over adjacent. And so you can use this knowledge here to figure out your answers. Okay, and so I know right now it might seem very weird what it's happening, but I assure you it's gonna click in a moment. See? So the unit circle, why is it called the unit circle? Why is it unit circle? It's called unit circle because the radius it has equals 1. It equals 1 unit. See? So notice all these different key points that I'm putting now. So this 1, 0, this 0, 1, this -1, 0, this 0, -1, right? All of these have a radius of 1. So all of these lines that are actually drawing onto it have a distance equal to 1. All of these have a distance of 1. Okay? All right, why is that useful to know? Because when you start thinking in terms of opposite over hypotenuse, well, all of these hypotenuses equal what? All those hypotenuses equal 1. Because the hypotenuse is the long part of your triangle. That is another thing I have to explain quickly. So your triangle, right? So you have a 90 degrees here. Your hypotenuse will always be this. Hypotenuse is always going to be the long side, period. Okay? So all of your hypotenuses equal to 1. So if you have sine x equals 1/2, that means that, thinking in so, right? If the hypotenuse equals 1, then your only option is that the whole opposite equals 1/2. Now, what is opposite in this context? So, the sine is always going to be, or all these angles, better said, is always going to be in respects to this. See? So, for example, you have this triangle here. Okay? So here you're doing sine theta in respect to that. And so the hypotenuse equals 1. And the opposite is all of this. And so the opposite, notice, it's my height. It's my y value then. So here, the height of this, the opposite of this, is 1/2. Oh, damn. So the opposite of this guy, right, just to practice, so the opposite of this guy is -1/2. Interesting. Okay. So now that we have that in mind, and you walk into the test having the unit circle memorized because it is something you have to do for this type of exercise, if you look at sine x equals 1/2, and you remember this SOHCAHTOA thing, and you say, okay, this guy on YouTube said all my hypotenuse is equal to 1 in the unit circle. So that means I need to look at, for sine, I need to look at the opposite, which is y values. Okay, so technically it's just y values. You gotta remember the unit circle and think, where do I have a y value of 1/2? Kapow, you have a y value of 1/2 here. Okay, so one of your answers, because it's in radians, is going to be pi/6. So the first answer, let me just be very organized, see? So one of your first answers for sine x equals 1/2. One of your first answers, so I'm going to put x1, one of your first answers is pi/6. Now let's not forget, we're always thinking between -pi and pi. So the answer you just got, is it within that realm? Yes, it is, right? Pi/6 is within that domain, see? So this is one of my answers for sure, okay? The other answer that you might have already noticed is that, okay, you have another y value that's 1/2. It's this one here. And so you say, okay, so my other answer is going to be 5 pi/6. Now, I'm sure at least one of you out there is saying, dude, what the heck? I don't want to remember this whole unit circle. That is insane. And I will answer, yes, it's crazy. And you do need to memorize a part of it, but not everything. And so you can pass from this to this with simple logic. I told you guys way earlier that pi is how much in degrees? Pi is 180 degrees. And so basically, because the unit circle is filled with like mirrors and stuff, the angle pi/6 here, the opposite of 1/2 here, is the same, if you think about it as a mirror, as the triangle over there. So how can you pass from one triangle to the other? Well, you can think about it as 180 degrees is this whole thing. So 180 minus this blue chunk here, right, makes you end up with the other side, okay? So basically, another way you can think about it is that you can do, if your first answer, the part you memorized, right? If your first answer was pi/6, in order to find the other one, all you have to do is do pi, which is basically 180, so you're finding the other side, pi minus pi/6. So for x2, you end up with, you amplify so that you can compare them, so it's 6 pi minus pi divided by 6. So your x2 is going to be 5 pi/6. So all you really did is that you found your x1, okay? And you did minus pi to your x1. So you did pi minus your x1. Sorry, so you do pi minus your x1. This gives you your x2. That is what I was trying to say. So if you do pi minus x1 for your x2, which is this line of math here, you can get the other side, okay? So again, you can either memorize the whole unit circle or memorize part of it and do the pi minus thing, okay? I suggest doing the pi minus thing, to each their own. So anyways, one of your solutions, as we said, is pi/6. The other one we said was 5 pi/6. Now, we're almost done, right? Because this is thinking about sine x equals 1/2. But the other answer that I got in my quadratic was sine x equals -1. So now we gotta go back to the unit circle and think about the scenario of sine x equals -1. So sine x equals -1, where would it be? Sine is for y values because it's the opposite. And hypotenuse equals 1. So where do I have a y value of -1? I only see 1. That was a lot of repeating. So it's right here. There's your value of -1. There is no other. And so this one's a little bit more friendly. Basically, your answer for this one is 3 pi, or the x1 you got for this one. See, think about it that way. So the x1 you got for this one was 3 pi over 2. Now, is 3 pi over 2 one of my answers? Is it within my domain? It's not, because your domain goes from -pi over to pi. If you want to see it graphically, so my domain is enclosed by the blue and green. There is my 3 pi over 2. It is to the right of the green, so it's not within my domain. So you do not consider it. Now, because this is a cycle that repeats always, you can do pi minus this guy, and you end up with the same sort of intersect, but here, which is going to be -pi over 2. So visually, that's what we're doing. So you do pi minus this guy here, you're going to end up with the same answer, but over there, because it's a cycle that always repeats. That's why this works. So x1 gave you 3 pi over 2, which does not work, not within the domain, but your x2 for this solution is going to be pi minus x1. So it's going to be pi minus 3 pi over 2. You leave it all in the same sort of fraction denominator thing. So it's going to be 2 pi minus 3 pi divided by 2, which is just -pi over 2. And so your last answer is -pi over 2. So basically, if you're more rigorous in your approach or in how you express your answer, better said, you're going to be putting as your final answer, and this is what the answer key says, your x values are going to be -pi over 2, because you put them in order, right? Comma, pi over 6, comma, 5 pi over 6. All right? So that is how you solve this exercise. It's very important to keep in mind for this last part, for finding the other solutions, you do pi minus whatever you got. See? So you do pi minus whatever you got, and that helps you jump from this to this here. See? Technically, in other exercises, you actually need to add or subtract 2 pi, and all that really makes you do is jump all the way over to like another sort of cycle, okay? And so adding or subtracting 2 pi just lets you go from one cycle to the next. And depending on your domain, because I mean my domain could have been much bigger, right? It could have been 2 pi. That's when that trick helps. The adding or subtracting 2 pi in case your domain is bigger. In this case, we didn't need to do that, but I'll point it out anyways because, well, I mean, I'm sure some of you out there need to figure that out. See? And last but not least, I would like to make an observation. See? This last part was hard. This last part took a lot of time and took a lot of knowledge, and you needed to know about the unit circle and a bunch of stuff. See? So take a moment, look at the answer key. So looking at the answer key, well, part A is worth 1 point, and it's a lot of formulas and stuff, and you gotta know what's going on. See, so that is a hard point to get, in my opinion. But then for part B, it's worth 5 points. And 4 of the points, dude, it's crazy. 4 of the points is just doing the thing of the quadratic and finding the x values. Finding the initial solutions, right? But the whole thing about the unit circle and the sine and the cosine and all that stuff is only worth 1 point. So I'm just pointing it out, you guys. Especially if you're low on time, do the part that is quick. Do the part that is just factoring and the quadratic, right? Think about it this way, you guys. This that I'm putting now in, let's say, light blue. See? So this that is in light blue, this is worth 4 points. And this that I'm putting in purple, this whole thing is worth 1 point. It's crazy. It's actually crazy. So if you have time, study with the mark scheme and notice what the IB gives more points of or less. Okay? Now, it could have been that this was worth, I don't know, 3 and this other one was worth 2. That can happen. Okay? It can happen. I feel like sometimes it's subjective. I'm not sure how they define it. I have no idea. But I'm just pointing it out, you guys. Do the quick part first. See? The part that is in light blue is something you should be able to practice and manage pretty quickly. And the part in purple, well, it's harder, and I'm sure sometimes it'll be worth maybe more than 1 point, but it's much more time consuming. Especially for a test. This is not just a test of math, you guys. It's also a test for your test taking skills. It's also a test with time. Your time is not infinite. It's not a lot, actually. So prioritize. Do the fast parts first, the hard part later, or the more consuming part later. See? All you care about is points. You don't care about answering everything perfectly. You care about getting the maximum amount of points, so use your time wisely. You should be answering at least a little bit on each question. Don't get stuck on the hard part and not end up doing other questions. See? I just want to point that out because I don't know, this isn't just a math channel, this is an IB channel. And I know you're going to be giving the May exams, the November exams, and I'd rather give all the tips and tricks I can. See? So keep that in mind, use your time wisely, and yeah, I hope it helped.